Today we do have the privilege of having Dr. Debi Prasad Das with us. Dr. Debi Prasad Das received the BSc Honours degree in Physics from Utkal University, Bhubaneswar in 1996. The MSc degree in Electronics from Sambalpur University, Burla in 1998, and PhD degree in Electronics and Instrumentation Engineering from NIT Rourkela in 2004. He has been working in CSIR research since 2005. In past, he has worked as a scientist in Central Electronics Engineering Research Institute, Pilani, Siri Pilani, during 2005 to 8. From 2008, he is working as CSIR, Institute of Minerals and Material Technology, IMMT, Bhubaneswar. Presently, he is a senior principal scientist and the head of Process Engineering and Instrumentation Department of CSIR IMMT, Bhubaneswar. He is the nodal scientist of the Jigyasa program of CSIR IMMT. Jigyasa is a scientist-student connect program of CSIR. Under Jigyasa, he has conducted several programs for school students at CSIR IMMT. He has completed guidance of 8 PhDs and 5 are continuing. So, sir has already guided 8 students, PhD students. He is working in the area of applications of electronics, instrumentation, signal processing, image processing, and machine learning for monitoring and controlling of mineral processing unit operations. In past, he has visited the University of Adelaide, Australia, and RMIT University, Melbourne for postdoctoral study. He has also guest faculty in IIT Bhubaneswar. Dr. Das is a recipient of Orissa Young Scientist Award in 2004, CSIR Young Scientist Award in 2009, Boys Class Fellowship from 2009-10 by DST India, NI Engineering Impact Award in 2014 in the runners-up. That AICT INA Distinguished Visiting Fellowship 2018. He is also selected as a mentor of change for Atal Tinkering Lab in 2018 by Niti Aayog, Government of India. So, sir is having a very brilliant introduction. I feel like having him here is a kind of privilege for all of us. So, I request Dr. Das to continue the session. Sir.
Thank you. Thank you for inviting and giving us an opportunity to talk to the researchers, the research scholars, students, faculty members of different parts of India. Hope you are energetic now or feeling drowsy after the notes. Okay, we'll try to make it interesting because this will be a different applications, but how we are applying AI/ML techniques to a different field, which area you may not be knowing. Okay, so purpose of showing you all this is having some kind of objective. Objective is any area you pick up, you can design an AI-based problem. And you can do some 7-8 days experiment, and then you can do some kind of coding, then you can publish a paper. Okay, so about 4-5 research papers we published in the area of application of machine learning in mineral processing, which I am going to explain. So I hope online participants are also listening. Am I audible to all? There? Hope it is.
Yes, sir.
Okay, thank you. The screens are also visible, right?
Yes, sir.
How to change? All right. Thank you. Let us quickly start. So, as the title says, applications of machine learning in mineral processing. Before I start the talk, I will tell something about my organization. it's working. Oh. They can press it. Okay. And okay, the title is probably not visible because of the online screen. So this shows back. Please go back. Go back. Yeah. Next. Yeah. So our institute is named as Institute of Minerals and Material Technology. It is a part of CSIR. CSIR stands for Council of Scientific and Industrial Research. You can see the map of India. Our labs are all across India, from Jammu to Trivandrum, from Jorhat to Bhavnagar, everywhere it is distributed. 37 laboratories are all over India, and all the labs are having different specializations. So if you talk about aerospace, then there is a lab called National Aerospace Laboratory. If you talk of glass and ceramic, there is a lab in Kolkata, CGCRI. Similarly, electronics, there is Siri Pilani. There is the National Physical Laboratory in Delhi. There are for leather research laboratory, National CLRI is there. Okay, chemical research, there is NCL, IICT. So there are varieties of research on different domains. There are different labs are established. So you all have a great scope in working there in various capacities, including becoming a scientist there. So our lab is situated in Bhubaneswar. It is named as IMMT at the moment. Earlier in 1964, it was established as a Regional Research Laboratory. And in 2007, it is renamed as Institute of Minerals and Materials Technology. Today, CSIR IMMD is the first choice for many mineral-based industries. Any mineral-based industries you talk of, they will come to IMMD. Why they come? Because the mineral industries, they depend on ores. Ores are mined from different kind of mines. Today, whatever is getting mined, tomorrow it will be something different. We do not know what is going to come. It is not like a well that every day same kind of water we are going to get. So what is there inside, we do not know. It may be high grade, may be low grade. Sometimes they are buying a new mine or taking a lease of a new mine. They do not know how to extract, how much the percentage of iron ore. What are the flows they have to process so that the iron ore can be profitably, they can extract the iron from there. Okay. Like our raw materials are there, we are preparing different type of curries and different type of food items. Similarly, ores are there, but these ores are not of same type. They are different, they are changing. Okay. Therefore, our lab is having different departments to cater to the mineral processing industries. They are advanced material technology, central characterization, any kind of ores or minerals or materials you can bring can be characterized by very sophisticated instruments, including our electron microscope, high resolution electron microscopes, and XRD. So many instruments are there, they can be characterized. Then we have material chemistries, design and project engineering, environment sustainability department, hydro and electrometallurgy, and mineral processing department. So mineral processing department mainly deals with ores and minerals from industries. They do a lot of processing and finally give a flow sheet and suggest the particular industry to apply the different unit operations in a particular sequence so that they can extract the minerals and ores in a particular in a maximum they can extract and in a profitable way with less energy consumption. And our department is a small department named as Process Engineering and Instrumentation. We develop a lot of processes. We develop a lot of instrumentation for different processes. So we have got three types of activities there. One is process instrumentation, where we use electronics instrumentation, signal processing, image processing, AI/ML techniques, IoT, soft sensing. All these we are using for developing process instrumentation. Similarly, process modeling, there is CFD, DM simulations are done for analyzing the process through modeling and simulation. Then molecular modeling at the molecular level, at the energy band diagram level. the material scientists also require modeling of different type of materials before they synthesize. So that is through molecular dynamics and density functional theory. Next. Yeah, why process instrumentation? As all of us know, that always there is a requirement of automation. I am giving an example of a washing machine. Earlier, you used to wash your clothes on a bucket, isn't it? How many of them used it? On a bucket, you put some surf or something, then stir it. Okay, everybody, like including me also. Then you have to soak it for some times and remove it and do it like this so that it will be clean. Okay. And some people thought this process is to be made automated. Okay. So for that, they made a motor to rotate, and there is a process to add the water and then rotation. Then sometimes some timer is set that up to this time this will be rotated. Then there is semi-automatic. After the everything is done, the cloth, the wet cloth is to be taken to another place. There it will be spun through centrifuge. The water will be going out. Otherwise, we have to squeeze it ourselves in the hand, and so squeezing is replaced by spinning. Okay, so the processes are different. It is not that again another motor will be there to squeeze it. So objective is to remove the water, not squeezing. Okay, so removing of water can be done by centrifugal method. That is why there is a perforated drum and it is spinning at a very high speed and it is coming out. Then why to have two different processes? Why there is manual intervention to remove the water from the cloth from this side to this side? So people made automatic. In the same drum itself, there are everything available. So you just put the cloth, some soap, and switch on. Automatically it will take the water, release the water, everything it will be done. So automatic. Now there also there are some problem. Again, some cloths it is not washing well, some cloths it is washing, it is removing the colors. So, but your mother or somebody experienced, he can wash there. And this is a thin cloth, this is a delicate cloth, I will use it for some less time, more time. That is why people use some fuzzy control or something. So AI/ML control also can be used there. Okay, this is a general application because you know about it. I just explained. Okay, now we'll go to the mineral processing. So industry requires different process, like a washing is one of the process. So automation is required, fault monitoring is required, then optimal performance. So the product should be optimally coming out. Not that some of the ores, some of the iron content is also left in the ore and they go in the reset. So optimal performance, energy efficient operation. Sometimes it is taking so much of megawatt of energy. Now we can do the same thing with lesser energy, so that it will be supporting to the carbon dioxide reduction in carbon dioxide and also the green energy. Reduce downtime, then networking the upstream and downstream. What is before that, from where this particular material is coming to this particular process, and after where it is going, they all should be coordinated. Okay, then industry 4.0, 5.0, all of you might have known. Then AI, machine learning algorithm can play a vital role in this kind of transformation. So the industries, old industries, okay, already previously established industries, they can introduce some of the AI/ML techniques with sensor and instrumentation to achieve all these things. Okay, they need not have to remove all the instruments and again buy a new set of instruments. They can also add some of the values, some of these techniques and add values to their process. Okay, so a lot of scopes are there. Next. Now, what is mineral process? So I will give an example. The left corner, I put one low grade ore. Okay, low grade ore means is an ore having lesser quantity of the valuable minerals which we are extracting. Like suppose iron ore. Iron ore, how much is iron content in it? Okay, it is 20% or 30%, 40% or 50% or 90%. Okay, so if it is my colleague is here, he is expert in mineral processing. He will stop me if I am speaking wrong in this particular area. He is Dr. S.P. Das. So I have brought him because we have done a lot of work together in the area of mineral processing and machine learning. So these ores, if it is a very high grade ore, then it is very easy for the industry to process and make profit. But while digging, suppose it's a low grade ore, there is only 45% of the iron content, or 40% of iron content, or 35% of iron content. So he's not interested in using it. Okay, he will throw it, just dig it and throw it, not use it. Okay, but these scientists, they play a big role there. So even if you have 35% or 45%, then we can tell you this is the process you follow, so that those 35% also you can extract. Okay, so what basically it is to be done? What is in the ore? Ore is having 40% means in this whole area, somewhere those iron oxides are present. Okay? Fe2O3 or Fe3O4, they are present. Hematite or magnet, they are present. And other places, some other materials like silica or some other things are available. Those are of no interest to us at the moment. Only the Fe2O3 or Fe3O4, hematite or magnetite, they have to be extracted. So how to extract it? So they have to first break it. Okay, break it to small pieces so that they will find that at some area there will be more content of iron, some other area there will be less content of iron, means more content of silica. So how they are different? Iron is heavier than the silica, so iron can be separated by a gravity-based method. So first process is to break them to smaller sizes, that is called combination or particle size reduction. So here I just shown some of the pictures where you can say that these are the small size areas where the iron content is more, other areas iron content is not much. Okay, so only when you break it to these pieces, you will find these iron content areas, they are separate. Now you have to separate them by some means. These white patches will be separated, the red patches will be separated after breaking. Okay, that is what is called combination. So how to break? Breaking to what size? Whether it is to be size to 1 centimeter or 1 millimeter or some micron size, depending on how well they are distributed. If they are distributed at a very finer size, okay, here 120 micron area, another 20 micron area there, another 20 micron. So you have to break into 20 micron size, or 200 micron size, or 1 mm size, depending on the how it is there. I think there are also some analysis by which you can tell that what is the liberation size, but what size you have to break so that you can easily separate. Okay, so there is a important mill called ball mill, which is being used in many places for grinding. There are other mills also. Then after the breakage, after the size reduction, then they have to be separated. Separation can be done by screening, you know. You have to shake it, there will be holes, screens, you know. Okay, sieving. Okay, method you can separate, or you can do some kind of classification. Gravity separation means you can put in a water and shake it so that heavier will settle down, lighter will be upside. Okay. There will be a method called hydrocyclone, you know, cyclone. So it is rotating, the air is rotating. So by that, what happens? The lighter particles which are there, the bottom they go up. All the houses are, the roofs are blown off, taken off outside to the top. Like this only, the water is to be made circulated. Water containing the ore fines will be circulated in a cyclone, that is called hydrocyclone. It will be circulated in this direction so that heavier will go down, lighter will go up. Okay, I will show one photograph, maybe it is there or not, I don't know. Okay, that's called hydrocyclone. Similarly, spiral, jig, these are all different kind of instruments which are used to separate after the breakage, after the grinding. These are required to do the size separation. Okay, they are separated based on density, based on weight, or based on the size. Okay, so different type of methods are used. There are some advanced techniques where the densities are almost similar, the weights are almost similar. Okay, like one is 5, another is 5.1. So the difference is not much, you cannot separate. So then you have to go for multi-gravity separation. Our G is 10 meter per second square. If you make it 100 or 200 or 500, what happens? If you multiply mass into gravity, the difference will be more. So there is multi-gravity separation also, it is there. Then you have to concentrate. So after that, you have to concentrate by magnetic separator. Magnetic separator means if the material is magnetic in nature. Some are non-magnetic, some are magnetic. So it will go in a conveyor. Then if it is magnetic, they will fall nearby. If it is non-magnetic, they will go and fall at a different place. Okay, so you can separate. Electrostatic separator means you just, electrostatic, static electricity, the comb you just rub on the hair and it can pick up papers, isn't it? We have studied in schools. So this is called electrostatics. So how to add charges to the comb surface? Okay, by friction. Similarly, if the particles are there in the dry state and you do a friction, okay, by mixing or by churning, you do some kind of friction so that some of the static charges will be attached to the body of those particles. Okay, sometimes they will be positive, sometimes negative. Then you have two electrodes, one is positive, another is negative, and you try to make them fall on that. So while falling, if they are positive, they will be attracted towards negative, they will fall this side, negative will fall this side. Okay, like this, you can separate the particles because the static electricity will be different for different type of materials. That is called electrostatic separator. So they are basically dry in separation. Magnetic separation can be dry or wet. With liquid, with water also you can put, or sometimes it will be dry also. Then some kind of chemicals can also be added. Okay, like oils or further they are said. So they will be attached to the material and they make bubbles, and these bubbles also carry some of the particles. They will take it off. Okay, like your surf you are putting, no, surf, how the dats are going up with the surf bubbles. Okay, like the detergent bubbles. Okay, like this, some of the particles can be taken out by that. They are called chemical separation or surface chemistry separation. So surface chemical properties, flotation and selective flocculation. Then after all these things, you put a lot of water into it. Then you have to remove the water. They are called dewatering. Then solid liquid separation. Then you have to dry it. Okay. After drying, they are all fines. Again, they will be fines. They cannot be again melted in the blast furnace. The blast furnace requires lumpy iron ores. Because for doing the beneficiation to extract the iron ore, you are doing what? You are grinding, making small size. You are adding water to classify them, separate them. Okay, that is why you have to dewater it, remove the water, dry it. Okay, then you have to again make them bigger particles. This is called agglomeration. Okay, add them together by some kind of binder. So there are three types of agglomeration: briquetting, sintering, and pelletization. So pellets are suitable for iron making. So those pellets, they can directly go to the blast furnace or directly they can reduce, okay, by DRI plants. So hope you understood the whole process of mineral processing. Now we can go to the next stage. This is called a flow sheet. Okay, like we do circuits. You all are electronics or computer science or what? Which subject? Computer science. So computer science also digital logic must have been taught. NAND gate, NOR gate, you just add them to make a circuit. Similarly, mineral processing also, they have a lot of circuits. So input is coming from here. Okay, from mine side, the ores are coming. Their big boulders may come. Okay, they have to be crossed by a crosser. Then they will go to the secondary crosser. Then there will be screening. Screening means bigger particles, smaller particles will be separated. Then there will be mixer. Sorry, crosser, secondary crosser, there will be smaller size. Then there will be a mill, rotary scrubber. So scrubber is to remove lot of, I think clays will be removed from the scrubbing. Then they will go to some other place, okay, like this. Finally, you get some kind of ore fines. These ore fines again come and there will be a storage mixing section. So they can be further ground by a ball mill. Then they will be mixed with some water and some kind of binder. Okay. So then they will come to the pelletization disc. Okay, the pelletization disc will make the pellets. Like I shown here the spherical balls. they are called pellets. Okay, so they will again make pellets, and these pellets are soft pellets because they are, you have made it from a soft iron ore, moist iron ore, so they are soft like lodu type. Okay, lodu, you know, soft lodu, but they cannot bear the load. If you keep one above other, they will be breaking. That is why we have to harden it. Okay, we have to harden it by baking process. You know baking. So you put in a furnace so that the moisture will go out and they become harder. Okay. So then the pellets will be coming. These pellets can be going to the blast furnace. Okay. They are all again iron oxide. Okay. So iron is not same as iron oxide. Iron Fe2O3 is there. So O has to be removed to make iron. Okay, Fe. So that is done in blast furnace. So inside blast furnace you add coke, then there will be reduction reaction will be there, then iron will be separated, molten iron will come, then you make lot of things. You know, we are using lot of irons, but you know, so many processes are there involved to get actually iron. It is very difficult. Now, can we use AIML technique to support mineral processing engineers? Okay, like washing the cloth, making a washing machine. Similarly, lot of instruments can be designed using AIML technique. Okay. So there are a lot of individual processes, like it is a grinding mill. Okay. This is a hydrocyclone. As I told you, it will be rotating. The water will go in a tangential direction and they will at a high force it will go, high flow rate, with high pressure, so that it will rotate. Okay, so that the coarser or the denser particle will go down and lighter will go up. Hydrocyclone. Then pelletizes uses a pelletization disc. Okay. So what is the job of the AIML technique? To correlate the process parameter with product quality. Suppose this particular mill. So what is process parameter? At what rotational speed the mill has to rotate? How much ball? Why it is called ball mill? Because inside there are some metal balls and the ores. Both will be rotated. Okay, there is no blade there to grind like our grinder mixer. There is no blade. Only balls are there and ores are there. They will be rotated. While rotating, it will not be very high speed. It will rotate to at a speed such that they will go up and fall down. Okay. There are some terminology he may be knowing. I forgot. Okay, they will go and fall. So along with the material, balls will also fall and they will grind. Okay, so you can make very fine particles. So there are process parameters. How many balls? How much balls you have to add? How much? What is the rotational speed? What will be the mill fill level so that grinding will be proper? If you grind a very fine size, it is of no use. Okay, they will all float and they will not settle. Okay, they are of no use. They cannot form pellets also. If you grind to a coarser size, again they will be screened. Again they will come back to the ball mill to grind again. Okay, so grinding is also an art. Every process is an art. That is why experienced engineers are engaged. They are hotcakes. They will never be removed from the company. Whatever demand they will give, this much salary they will give and keep them because they are handling the grinding. Okay. But we can use AIML to train and replace or have substitute to those experienced people. Okay. Because they can, whatever they are doing, he is one person. Okay. He may take leave or he may, we are not removing their job, but we are giving a substitute. He need not be staying there all day and night in the shop floor in a dusty environment and monitoring and doing the operation. Okay. But we are making something because tomorrow, suppose people will not study mineral processing, all will study computer science. How will you stay? So we have to make engineers. Okay, not by human being, but by using AIML techniques. So monitoring the operating condition, the mill is rotating, whether it is grinding or not grinding, or it is only no material is inside, it is only rotating. Okay, we do not see inside because it's a big opaque metallic cylinder. We cannot see what is going on inside. So from outside, how to know what is happening there? Classification of faults. So it may be not generating the output properly. Okay, it may be creating a sound. So what could be the fault? Monitoring difficult to monitor process parameters, soft sensing, okay, where no sensors are available. So there are, can I say how much ball is there inside the ball mill from outside? Which sensor I will use? Suppose I want to put a sensor to monitor how much ball is there inside. 10% of the whole volume is filled with balls, 20%, whether balls are broken or balls are okay. Whether balls are coated with some moist material, so that is not having a grinding ability. Okay, it is having a cushioning ability. So it's not properly striking because some muddy things are actually attached, sticky things are attached. So can I monitor from outside? So there is no sensor available. I can measure a temperature, I can measure pressure, I can measure flow, but I cannot measure whether how much is the ball content inside, whether balls are broken or still there in good condition. That is why they are called soft sensing. So by using software, we have to sense. By using indirect method, we have to sense. So replacing human-based monitoring in hazardous and tedious situations. So human being has to, because the plants run 24/7. Okay, they don't stop. So night also, some people have to monitor. Day also. Okay. Earlier days, people are very dedicated. They have been given the job means they will work. But now, night shift, they will go and sleep. And mobile is there, they will do Facebook, WhatsApp, not attentive to the process. So how the Tata, Birla, the Jindal, they will know, the top management will not know that because of the negligence of the worker, it is not happening. Production is poor. Okay, they have some target, they are trying to achieve, but not optimally there. They can operate because human being. Our mindsets are changing, so we have to be dependent on machines. Machines having human-like intelligence. Okay, not such machines which are earlier days machines. Now human-like machines are required. So as all of you know, artificial intelligence, we are intelligent because we have lot of sense organs. We can see, we can smell, we can taste, we can hear, and we can touch. Okay. So the theory of development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception. He can see and do. Why the operator is capable of doing? Because he can see, he can listen, he can smell, he can also touch and say that this vibration is not good. Okay. So all these are there. They have the sense organ. Also, there is a brain. Okay. Now, if we are going to make a machine, we should have all these sense organs and also a brain. The sense organs can be for eye, I can put a camera. For hearing, we can put a microphone. For smell, we can put some kind of gas sensors. For taste, we can put some kind of chemical sensors. And for touch, we can have some vibration sensors. Okay. And for the brain, we have a computer having Python program. AI-based learning. Okay. And then everything is interfaced. Now you get a artificial engineer, isn't it? Artificial intelligence can make artificial engineers or supervisors in the industry. Learning having supervised, unsupervised reinforcement learning, all these can be used there. All the varieties of machine learning, whatever is there, they can be used in mineral processing. So in a mineral machine learning, all of you know that machine learning means what? A machine has to learn. What does it mean? We have a brain, we are capable of learning. Okay? A chair cannot learn, a table cannot learn, this particular room cannot learn. They don't have brain. Suppose we want to make a machine to learn means we have to create what? We have to create a mathematical model. Okay, it is an equation. And equation has got some input is a function. Okay, so x is the input, f of x is the output, and you have got a0, a1 on the parameters. Okay, these parameters are tunable or adaptable depending on the input and output. So if I give a set of inputs, the equation will be such that this will generate the required output. Whatever is the output, that will keep coming. Okay, then this is called the machine learning model. So for learning the machine, I have to have inputs and outputs, and then the parameters has to be tuned. All of you know about it. Yes or no? How many of you use a machine learning? Can you please raise your hand? If some have not never used. How many of you know neural network? At least know about neural network. Okay. And CNN, deep learning. CNN also some of them. So we have applied neural network in CNN. How we have applied, we'll let you know. Then the model means a mathematical equation. Okay. So those who have never studied anything about machine learning also, they can understand about it. So we have a set of x and set of y. Okay. And I can write an equation y equal to mx plus c is a straight line equation. Okay. But I do not know what is my m value and c value. Okay, m is here a1, so this is multiplied with x is m, and c is the bias. Okay, is a constant, or in your straight line it is called y intercept. Okay, so if I got x and y, both are there, series of x, many values of x and many values of y, then there are methods by which I can make a0 and a1. So once I make a0 and a1, I get the equation. Then any x I give, I can easily get y. Okay, even if that is not there in the table. Okay, that is called a model, trained model. Okay, but if it is not a linear one, it is a non-linear, then I can have x square, x cube, x to the power 4, x to the power 5. Okay, this will be non-linear model. Similarly, we can have different kind of non-linear models, including artificial neural network. It's a multi-layer neural network. There are some other varieties of computation, having some other functions, some other interconnects. Okay, but basically that is also a set of equation, or that is one equation, closed form equation, where input is x and output is y. Okay, their equation may not be same. And after training, by giving the set of data, we have to train it so that I get the optimal parameter. After I get the optimal parameter, I can test it by giving the inputs and see that whether my model is correctly predicting or not. We will have a lot of examples. Okay, in mineral processing domain, how we are applying. Many people are sleeping. Don't sleep at least. Those who are feeling sleepy, they can go out, drink a little water and come back. How many are feeling sleepy? नींद किसको आ रहा है? कितने लोगों को नींद आ रहा है खाने के बाद? Raise your hand. थोड़ा थोड़ा किसको आ रहा है मैं देखा क्योंकि because I am a human being, I am capable of knowing this. So by just watching your face, I can say you are feeling sleepy or you are attentive or you are thinking something else. Can I put a camera here and a machine learning algorithm to say that among these many people, these are feeling sleepy? Yes, this is a good problem, isn't it? So you can easily do it. So you first take the video of your class. Okay, after lunch you make the class. Okay, this is how you collect the data. After lunch, then collect the video, CCTV video. Okay, take all the frames and you yourself watch, detect them. Okay, level, that is called leveling. Okay, you level them. These are the people sleeping. Okay, then next day you train it. Okay, all these after leveling, among them, these are feeling sleepy. These are attentive. These are the people, they are looking like attentive, but they are thinking something else. That is also possible, isn't it? They are attentive, looking like they saw that we are listening, turning the heads and okay, but they may be thinking that my mobus will go or my hostel food is not good or maybe some WhatsApp has come, I have to attend, isn't it? So this is also a machine learning problem. Okay, so there are a lot of structures. So this can be called as one structure. Similarly, varieties of structures you can do so that you can compare and publish a paper. So all of you might have come here to publish paper. What is the purpose? Or develop a system we can sell and make money. What is the purpose of coming here?
Publish.
All are published paper. Anybody having to make money by selling products? कितने लोगों को खाली पब्लिश पेपर पे खुश होना है, कितने लोगों को उसको बना के बेच के करोड़पति होना है? You can raise your hand. Publish paper how many? Few, only few. And how many not publishing paper? Not interested in publishing. Not interested. So what you are interested for? Why you have come for certificate? For what?
For gaining knowledge and
After gaining knowledge, where you will apply?
making product.
Making product, very good. So that should be the spirit now. We have to make products so that we can sell it. We will tell you some of the products we have made and it is also sold in the market. Okay. So how to make the product and sell? So all of you know about artificial neural network, which is biological neural network having inputs and outputs. Input is dendrite and output is biological. Output is option. Okay. So either it is written. So the inputs are taken through a network and these outputs are connected to another set of inputs. Okay, like this, our sensor organ takes the data to the brain and that way the biological neural network is made. The mathematicians, the computer scientists, they thought, can you make a natural or can you replace the natural neural network by artificial neural network? So they also made similar interconnects and inputs, hidden and outputs, and have mathematics, there is computation and computer coding by which they could able to replace, not replace, mimic the biological neural network, whatever job the biological neural network is doing to match the patterns. Okay. This neural network also can match the input and output pattern. So if you go deep into it, like you wanted to learn. So nowadays, if you use Python codes or MATLAB codes, then you don't have to know about what is the mathematics behind backpropagation. Okay. But if you want to code yourself, you want to design a new neural network which never people have seen. Okay, a new kind of function. Then you have to know what is the basis on which the neural network was initially established. What is that gradient descent method? How the gradient of error propagates from the outside to the inside, how it is back propagated. Okay. So there are activation functions like this. There are many varieties of activation functions also people use. These activation functions are used to add non-linearity to the neural network model. Okay. Then what you want to optimize? You want to minimize the error, or you want to increase the profit, or you want to improve the something. So that is to be taken as cost function. Okay. So there are varieties of cost functions available for different kind of applications. Regression is a type of problem. Classification is also another type of problem. We'll see through example. Okay, I am coming to some of the unit operations on which we have applied the artificial intelligence technique, or particularly machine learning. This is called a ball mill. As I told you, this particular core is to be ground to smaller size. You can show here it is shown Some are reddish, some are blue. Okay. So I can say red is some kind of mineral, blue is some kind of mineral. So you have to break into this size so that, or similar size so that this can be separated from that based on the density. So this inside of a ball mill where there are balls available. There are metallic balls. Okay. And this is a grinding mill. This rotates like this, so coarser particle will go inside and fine particles will come out. So this is a setup in our lab, which is a ball mill as well as classifier separate. They can do it. Okay. So grinding is required to liberate the valuable minerals, as valuable minerals are distributed throughout and concentrated in small areas. That is why we have to grind it to smaller size. What are the issues available? What are the issues now there in a particular conventional ball mill? So product size should not be too big or too fine. While grinding sometimes becomes very fine, sometimes it's too big. Core characteristic also change. That is why the grinding performance is also not good. Then monitoring of the condition inside the mill, whether the balls are broken or what is the condition, or it is coated with something else. Okay. Mill field, ball condition, lifter liner. So while it is moving, there are some lifters like this kind of bars are there. They will take the material offside. These are also, they can also be broken. Okay. Then since it is very energy intensive, whether I have to grind it continuously for 1 hour or within 30 minutes is also complete. Okay. It runs through human supervision and intermittent laboratory analysis. So these finds are taken to the laboratory, they can run the sieving and then check that now performance is okay. Otherwise, they will change the parameters. So they will feed more material or less material. Like this, some control process parameters can be changed, like feeding, water addition, ball percentage, so many things can be changed to achieve the proper grinding. Okay. So in this case, our objective is to apply AI/ML to circumvent some of these issues. So we made a small effort of monitoring the fill level of the ball mill using vibration sensing and artificial neural. So this is a mill. This is called tumbling mill. Okay, our Dr. S.P. Das established this particular setup, and we got a chance to work with him through a DST project, and lot of experiments he did. So what is the specialty in this instrument? It is having lot of sensors. This is a force sensor. This is the accelerometer sensor. There are torque sensors here. So many sensors are there attached to this mill. Unlike a commercial mill where there is no sensor, they only have to rotate and you get the result, get the grinding outcome. But here, to do the experiments and to analyze, we have a lot of sensors here. Okay. So one experiment which is published recently is how to know the fill level. So we put some 10% material, then collected the vibration. 20% material rotated for 1 minute or 2 minutes or 5 minutes, collected the vibration. 30% material vibration collection. Like this, all percentage from 10% to 50%, 60% will be collected. Okay. After collection, we have sensor data. Now objective is, if I get the vibration signal, can you say what is the mill fill level? It's not visible to outside, isn't it? It's a simple machine learning problem. We have input is vibration signal, isn't it? Vibration signal also, to do the experiment, we put knowingly the material, 10%, 20%, 30% of volume. Okay, fill it and collected all the vibrations. Okay. Now we know that these vibrations are collected when it is 10% fill. These vibrations are collected when it is 20% fill. These vibrations are collected 30%, 40%, 50%. So we have a lot of vibration signal. Now, how I will feed this vibration signal to my neural network so that my fill percentage can be as the output of the neural network. As you know, vibration is a zigzag signal, isn't it? So I will show you a sample vibration signal. So it will be the vibration signal will look like this. The oscilloscope or somewhere you will see it will be up and down, depending on the vibration. Okay. And the amplitude may change or the frequency content may change. So many parameters can change. But our objective is if at least 1 second of the vibration data is given, only 1 second of vibration data is given. Okay? And this vibration is sampled at 20 kilohertz. 20 kilohertz means or 10 kilohertz means in 1 second we have 10,000 samples. In 1 second we have 10,000 samples. So these 10,000 samples are given to me. Then I have to tell what is the field level. Okay. So these 10,000 samples I can do FFT, fast Fourier transform, DWT, WPT, Wavelet packet decomposition, empirical mode decomposition. So many tools are there. You can put them so that you get a lot of features. For FFT you get some feature, DWT you get some feature, Wavelet packet decomposition get some feature, EMD you get some features. These features are finite in number, maybe 1 to L, 1 to 20, maybe 10 features. They are numbers. We have 10,000 samples. We did some signal processing, digital signal processing, FFT, DFT, or some other things, and got only 10 numbers. For this 1 second of data, 10 numbers. And these 10 numbers are the representative of my field level. Okay. So then we kept it. So from suppose I have 1 minute of data, 1 second data I am taking. So how many data I can generate like this? 60. Huh? 1 second, 1 data. So I have got 1 minute data. So 60 varieties of data I can get. I can get infinite number of data. Not infinite, means more than 60, because I did not start from here and go up to 1 second. I can also move one or two samples and again another 1 second. I can move little bit another second, 1 second. I did not take 1 second and leave all the 1 second and take from here. Okay. I can shift it and take second, like this. So many varieties of data I can generate with a starting point at some place and take 10,000 samples. Starting point anywhere you can choose a starting point and you can choose the data. Okay, so you have a lot of data. Just by 1 minute of experiment, you can have so much of data for machine learning. So then vibration signal of 1 second, feature extraction, ANN based training. Now you can see this is a good model with a good number of features. So all features are not good. Okay, all features are not good. So with some features, I am showing only 2 examples, 2 results. So many results are there in this particular journal, Neural Computing and Application. So this point shows that what is the output. Output is showing about 9%, but actually it is 10%. It is 9, 11, something like this. So all the points are almost on the line. 2 points are a little bit deviated. So all these are the output of the neural network taking the vibration signal captured during 1% filling level. All are not used in training. Some are kept for testing. You can see almost it is matching. But here in this model not matching. So you have to show the comparison where it is matching, where it is not matching. So many other results are given. That is why it is complex. So you come to know about a problem, how it is addressed, how to measure the field level of the ball pit. Suppose some of you want to do one small machine learning algorithm for knowing the grinding of your grinder. You know, in your home there is grinding, isn't it? So suppose you put some kind of some ginger or some urad dal or some other thing to start. Okay. When you start, then there will be some sound, isn't it? You record in using your mobile phone, sound recorder. Okay. Then from starting to end you record. Okay, you can find that this is at the starting sound, this is the middle sound, this is the end sound. Okay, so 1 minute you record, 2 minutes you record, 3 minutes you record, 4 minutes you record. You can say that up to how much minute I rotate, means keep it so that it will be grind. Okay, then you put different quantity of material. Okay, 1%, 2%, 3%, 5%, till level. Then you get a lot of sound signal. Then you apply, make a automatic grinding. Okay, so you put the urad dal and go to office. So it will be ground, fermented, everything, and it will be ready. You need not stay there and listen all the noise from the grinder and work. Okay, so machine learning is applied there. Now there is another interesting problem we designed. I'll tell about the process. This is called a hydrogen plasma. Okay. What is plasma? You know, inside the bulb and tube lights, there is a plasma there. Okay, tube lights. Plasma, you know, fourth state of matter. Gas, solid, liquid. Solid, you have atoms, molecules, they are attached. Okay, so they are solid. Little apart, they will be liquid so that they can flow. Okay, even gas, they are very much free. They can go to anywhere if it is not bounded. Okay, but plasma is a hot gas. You can see. If you increase the temperature of the gas or increase the energy of the gas, then some of the gas molecules or atoms, they will release the electron. Okay, so in a plasma there will be some ions, electrons, as well as some of the neutral gases. Okay, that is called plasma. So there will be electrons, free electrons. There will be some ions. Those who are left the electrons, there will be ions, and there will be some neutrals also. Not necessarily all are ionized. Some are neutrals also available. So how it is made, you know, sparks. So two wires if you touch, having energy, there will be a spark, isn't it? By this method, the spark is also a plasma. Why the glow is coming? When there is a spark, there is a glow coming, isn't it? Light coming. Why? Because some electrons are emitting energy in the form of radiation. You know, electron when jumps high school level from higher energy, lower energy to higher lower energy by getting energy. While coming down, they will release the energy in the form of radiation. That is called the glow. How much time I have? So I will quick. Now you can see these are the two electrodes. One is negative, another is positive. They are actually touched and a plasma is created. That kind of arc is created, and some gas is fed there. So this gas is getting ionized. That is called plasma. Okay. So the electrons will be there, ions will be there. They will be moving. Electrons will move from cathode to anode. So it will create a very high temperature zone. High temperature of the order of 10,000 degree, 5,000 degree, which is not possible by a normal heater. So there is a kind of mineral processing going on. So some hematite granules are there, and hydrogen gas is there. You know hematite, magnetite. Hematite is Fe2O3. Okay, iron oxide Fe2O3, magnetite Fe3O4. Okay, so hematite means Fe2O3 is there. Our oxygen has to be removed. Okay, blast furnace में क्या होता है? Blast furnace, iron oxide and coke is given. Coke means carbon. Then oxygen combines with carbon, becomes CO2. Okay, it is a polluting gas, and iron is created. So blast furnace generates lot of carbon dioxide. So जितना भी हम iron use कर रहे हैं, इतना air को pollute कर रहे हैं. तो IMMT में we are working towards making of iron without using carbon. Okay, so carbon अगर नहीं है तो how to remove the oxygen? Can we use hydrogen? So hydrogen is used. So in this plasma you give the hydrogen gas, so that hydrogen will remove the oxygen and it will go as water, H2O, and iron will. So it is a novel process. तो उसमें hydrogen use होता है, hydrogen is explosive, isn't it? Hydrogen is, it may, if it is released to the atmosphere by some means, it is very dangerous. Okay, it will catch fire, isn't it? So for that we use argon and hydrogen mixture and put it here. Okay. Now to know how much is the hydrogen flow, we have flow meters. Okay, so hydrogen comes from hydrogen cylinder. There are flow meters to tell that this is the percentage of hydrogen. Okay. Now our flow rate is this much, this liters per minute. Now suppose हमारा flow rate खराब हो गया. Suppose flow meter यहाँ पे चेक कर रहा है, लेकिन यहाँ पे लीकेज हो गया बाहर. Suppose there is a leakage from somewhere else. So how to know that whether whatever is the hydrogen released from the or coming out from the cylinder is all going to the plasma or not? वो हमारा objective है. So can we see the plasma color? Plasma का जो color है, उसको देख के can we say that this much of hydrogen is coming? Are you getting how we are designing a problem, machine learning problem? इसका कलर देख के हम बता सकते हैं कि कितना वोल्टेज उसको जा रहा है. 230 वोल्ट है कि अभी 100 वोल्ट है कि कलर से पता चल सकता है. एक लाइट डिम हो गया, लो वोल्टेज में फैन घूम रहा है, स्लो हो गया. कैन वी टेल स्लो हो गया मतलब अभी वोल्टेज 180 वोल्ट है, अभी 200 वोल्ट है. इज इट पॉसिबल? बिकॉज वी आर इंटेलिजेंट, वी नो दैट जब वोल्टेज डाउन होता है तब हमारा स्लो हो जाता है. सपोज करंट है और करंट चला गया, इन्वर्टर से चल रहा है तो थोड़ा स्लो चल रहा है. तो वी आर इंटेलिजेंट, वी आर एबल टू नो इट, रिलेट इट. Similarly, can we see the plasma by a optical fiber and a spectrograph and then tell through a ANN model that this is the hydrogen flow rate? That was our problem. And this is the spectra of the plasma. As you may not be knowing, that any light consists of lot of wavelengths, like your visible light having Hipgoy, violet to red. All these are individual wavelengths. Okay, 400 nanometer to 700 nanometer. But in a plasma, there are so many wavelengths of different gases. So argon gas will create a lot of wavelengths. They are called emission lines. Hydrogen will create one emission line. So here emission line will be related to the plasma condition. Okay, plasma का energy क्या है, power क्या है, और उसका उसमें कौन सा गैस है, all this उसके ऊपर ये depend करता है. This depends on all these factors. Our objective is, if this particular plot is given, can I tell that at what flow rate of the hydrogen gas is this particular spectra is coming? And plasma is very dynamic. It's not all the time it will be constant. It will be changing. Sometimes this will go up, this will come down. Sometimes at the same flow rate, there will be a lot of variability. It's not one image. Okay. Every time, like suppose I am watching her. Okay, black side. I am watching her. Okay. Tomorrow she will come with a red dress. Sometimes the cap. Some other time, some other dress. Whether I will be able to identify all the time or not. Unless I am not intelligent. Okay. Or suppose it's just a camera, it cannot recognize. So we have to be all the time we have to training ourselves. Okay. So if it is all the time same image will come, there is no problem. There is no need of any neural network or machine learning. Since there is a variability of your input, it may change. Okay. The picture will change. Like this, the spectra will change. Under the same condition also it will change. So for all varieties of conditions, you have to train and say that these conditions are for this particular flow rate. That is why we require a lot of data, a lot of varieties of data. Okay. So then in this particular case, we have taken some of the these peaks are there. Okay, the height of the peak, the width of the peak. If we zoom it, there will be a width also. It's not a single line. There will be called full width at half maximum, FWH, the width and height of all the lines, hydrogen lines, argon lines, everything were taken. And we could able to do a lot of training and found the mean square error by varying the step size and the hidden node. Then we are capable of monitoring. We had actually 4 experiments. Okay, not much, okay, because very difficult to run the plasma. So 5 LPM, 8 LPM, 10 LPM, and 12 LPM. Okay. And there are some data. Okay, few data we kept for training, and some we kept for testing. So we are finding that from the spectra we are capable of finding out the flow rate very accurately. Okay. This also got quickly published in neural computing applications, because they found it's a new kind of application. Okay. And why it is required? It's an indirect way of estimating hydrogen chloride. Hydrogen chloride meters are available; they can measure. But what we are showing, how we are posing the problem. We have to pose the problem in such a way that it is required. Your work is really needed. Okay. We are saying that chloride is here, but is going there with the pipe and getting into the plasma. Okay. Suppose flow meter is showing that it's going, but there is a leakage. It's not really going to the plasma. Then on the plasma color, where they are the destination, like your students, AAA students, they are coming out from the home, but they are not coming into the college. Okay. So from the college CCTV camera, they should know that people are actually coming or not. घर में तो सब बोलेंगे सब जा रहे हैं, दिल्ली जा रहे हैं, तो वहां से होके वो कहीं और चला गया, इधर नहीं है, वही चीज हमको इसको बोलते हैं redundant sensor. ये भी पब्लिश हुआ है. So is it interesting or boring?
It's interesting.
So you have to design your own problem, not necessarily the same. So again, the same plasma in a different furnace. This is called the cathode, this is called the anode. Okay. So there will be two electrodes, they will be touching, so that plasma will be created, and you have to move it off so that this area there is plasma. Okay. And this is a cylindrical area, and there is a cathode cylinder which is getting inside. Okay. This is a crucible. This is like a what is called cylindrical pot, hollow. Okay. Another is going there, and the whole plasma is created inside. मेरा ऑब्जेक्टिव है बाहर से देख के कहने से ये कितना अंदर घुसा है, ठीक है ना? What is the height of the cathode from the bottom? तो बॉटम कितना हाइट में है, बाहर से नहीं दिख रहा है, कैमरा नहीं लगा सकता क्योंकि इट इज वेरी हाई टेम्परेचर. तो हम लोग क्या किया, इसका वोल्टेज कैप्चर किया, ये दोनों के बीच में वोल्टेज, कैथोड और एनोड के बीच में कांस्टेंट करंट फ्लो कर रहा है, दोनों का वोल्टेज जितना डिस्टेंस हाई होगा उतना वोल्टेज ज्यादा होगा. ठीक है, वोल्टेज धीरे धीरे इंक्रीज होगा बिकॉज देयर विल बी इंपेडेंस और रेजिस्टेंस इन बिटवीन. ओके, करंट इज कांस्टेंट. सो देन we captured all the voltages, okay, at a very high sampling frequency, 100 ampere to 125 ampere, 150 ampere में capture किया. So these are all voltage signals. Now these voltage and these are the cathode position, okay, at different height. अभी ये जो अगर blue color का signal मुझे दे रहे हैं, can I say what position the cathode is there? They are nearly increasing, okay, nearly increasing, but sometimes they are also going up and down like this. So this is the problem. Means giving this as input, this and ampere current, both are input. I have to predict the steps, this position of the cathode. So this is the result. We are, to some extent, we are capable of predicting. So these red things are our output, and this is the actual. Okay. This is also 50. So it is showing around 39 to 60, sometimes 60. Okay, somewhere there is more error, somewhere less error. But it is giving some result. But still there is scope of improvement. So this is also published in IEEE transaction plasma science. Okay. You can see how they are using ML algorithm, neural network. So machine learning based next, all these are signals, vibrations, voltage, all these are signals. Okay, now we are going for image processing. So in a, how the images, as I told you, I put the camera and tell you who are filling CLP, who are attentive, who are not attentive on the image. Because I have to do the image as the input and do the processing, machine learning. So feature extraction करना पड़ेगा image का, then use ANN. Or directly use a deep learning where there is no need of feature extraction. Directly you can use the convolutional level. Those who have, I think this particular workshop is on deep learning. So CNN must be taught to you in a better way. So I'll tell a little bit about the CNN. So applied for segmentation, object detection, classification, lot of applications are there. Visual perception. A doctor can see the X-ray image and diagnose. Can I do? X-ray image is given. I cannot do because I am not trained. He or she is trained. That is, she is capable of checking. So you have to actually train the computer so that X-ray image, the computer can see the exam papers. How many varieties of handwriting the students will write? Okay. But your teacher is so intelligent that he is or she is capable of checking it, isn't it? The engineers can see the particular wiring and find out the fault. Driver can be made automated. It can drive. Driver is capable of driving, isn't it? How much the speed to be maintained, what is the road condition, all this he is capable because he has been trained in the beginning, okay, got the license, as well as he is gaining the experience by going to that particular road again and again. One simple application of CNN, just to show you, if you are new to the CNN, there was a problem of handwritten character recognition. Okay, earlier days, the postcards, now there is no postcard, WhatsApp is there. Handwritten, the pin codes are written in handwritten. You know how many have seen postcards? Letters in senior group. Many people have not seen this, people have not seen authentic signature. You have to keep in museum the postcard. So you know pin numbers, isn't it? So they were actually written by hand. Many people can write by hand. Then postmaster or the post peon, they will check. Okay, those will be distributing. And this is for this area, this for this area, they will sort it. Every post sorting things. So Americans, they thought making automated things so that handwritten postcards also the numbers will be computerized and automatically it will be sorted. So for that they used some kind of machine learning. So the 3 can be 3, okay, by so many neural network. It is just not a multiplication, division, or addition. There are convolution, there are pulling, okay. So there are methods. Okay? So this is a kind of, so basically there will be feature extraction, isn't it? So why it is called 3? Because this is carved like this. Okay, there are 3 points here. That is why it is 3. I am not saying it is 7 or 8, because 8 means this side should be closed. Because I have been trained. So neural network or the CNN convolutional neural network, that should be trained. Okay, so it will extract the images, extract the features, and then classify. So from 0 to 9, this will match to one of the numbers. Okay, match means there will be some outputs, but these 3 will have maximum outputs. That is why it is called 3. It is called a classification problem. So we use this particular concept. Next. Okay, to do a visual perception based process monitoring. Visual perception based process. We went to the industry. We found that a particular process called pelletization. The pellets are made in a disc like this, big disc like this, and pellets are falling. Okay. So these pellets are spherical balls. Okay, and these balls is rotated. This is a process. I'm telling you, explaining in a layman's language. You may be knowing there are some beetles, okay, some insects. They roll the sands and make balls. Okay, or you can say the laddu makers, those who make laddu from bundi. So, you know, so they can roll on the hand and make spherical balls, isn't it? So similar is the process. There are iron ore fines. There will be some kind of binder. Binder means some kind of glue kind of thing you can say, and some moisture, that is water. It's a moist material, and they will go up in a disc. It's a big disc, so they will go up. They will basically be rotated. They will go up. It's a slanting disc. Okay, they will go up. Try to imagine it will go up and fall down. Okay, while going up and fall down, because they are sticky in nature, they will roll over another and they will make small balls. Okay, these balls will slowly grow. Okay, slowly grow and it will make bigger balls. Okay, and after it becomes a bigger size, they will come out from the disc, and this is called the product of the pelletization disc. So fines are input and they rotate, and finally the pellets are generated. Because of if it is more moisture, then maybe it will be bigger pellets. If it is less moisture, maybe smaller pellets. The smaller and bigger are of no use. They will be again coming back to the grinding, or again coming back to the, if they are smaller, again they will fall in this disc and again work, they will be growing. If it is bigger than desired, they will be again broken, again coming back. So it's called recycling. That is why one experienced person, one or two experienced person will move around and watching similar discs. There will be 7, 8 discs will be there in a plant. Okay, 10 discs also there are in some plant. So they will move here and there and watch the size. If it is growing, they will rotate the speed. They will reduce the speed. What happens if they reduce the speed? Whatever speed it is going, they will be slower. If it is slower, then it will go lesser height, isn't it? If it is higher speed, it will go more height and fall. If it is slower, go to less height and fall. If it is flowing from a bigger height, then more rolling will be there, size will be bigger. Lesser speed will be falling from a lesser height, so size will be less. So by controlling manually, they were controlled. We thought, can we not make it automated by putting a camera? So what he basically is doing is checking. He is not measuring by hand what is small, what is big, saying whether it bada ho gaya ya chota ho. So this is a what type of problem? The classification problem, isn't it? It's a classification problem. देख के पता करना है कि ये बड़ा है कि छोटा है कि नहीं? इतना लोग है, हम देख के बता सकते हैं हुआ taller, हुआ shorter, ऐसा no. Similarly, pellet को देख के हम बता सकते हैं ये बड़ा है कि छोटा है. अगर साइज पता चल गया तो हम कंट्रोल कर सकते हैं. तो ये वाला सिस्टम को हमने नाम दिया आई ऑन pellet. Okay, and this eye on pellet is adopted in industries, and you can make similar systems for different type of industries which are visually observable. People are observing and taking a decision to control. You can make such systems. So there also we use a lot of these names. How many of you know these names? BGG16, MobileNet, ResNet. So yeah, good. So if you study CNN, convolutional neural network, there will be varieties of convolutional neural network. Those are pre-trained, already trained with for some other applications. Okay, and you can use them for your applications by modifying something. This is called transfer learning. Okay, so we use this to just say that it is very small or good or big or very big. Okay. Now, the most difficult challenge was how to know how to collect the data, big size data, small size data, and very small size data. If I ask the industry that now run the industry to generate bigger size data, you will not follow because their production will be at loss, isn't it? Production होगा, production loss होगा. कभी कभी unstable हो जाएगा तो डिस्क को फिर stable condition में नहीं ला पाएगा. So you will not. कभी भी हम बहुत बार बोला और नहीं किया, नहीं हम नहीं चलाएं. ठीक है, अब हम नॉर्मल में चलाएं, उसी से जो करना है कीजिए. तो हम क्या किया, नॉर्मल इमेज लाके उसको बड़ा छोटा करते हैं. Very good. So there is a terminology called data augmentation. Data नहीं है, data generate करना है. कैसे करेंगे? तो देखो एक इमेज है, ठीक है, एक इमेज है, उसको थोड़ा हम काट देंगे चारों तरफ, फिर उसको उतना स्ट्रेच कर देंगे, तो क्या दिखेगा? तो पैलेट क्लास बड़ा दिखेगा, छोटा दिखेगा?
Stretched.
हाँ, अभी काट कर दिया चारों तरफ से, फिर उसको स्ट्रेच कर दिया, तो जो छोटा था वो बड़ा दिखेगा.
So the blurriness will be increased, I guess.
Whatever. log may be increased, whatever, but we have a very high resolution
Okay.
thing. So again, when you enter into CNN, it will be again reduced the size. Okay. So this terminology we gave for the first time called crop and resize. Crop it, resize, crop it, resize. And we collected varieties. Same image you can see. This is looking bigger pellets. This is looking smaller pellets. Some little innovation you have to add so that it can be a paper. So then we same image. This is very small, which is actual. Okay, then slowly you can increase, and you can say this is good, this is small, this is very small, and read the classification. All this, if you apply them, then the Python will generate all this confusion matrix. Then this is how we plotted. But this is very small. We have so many data. Now, if I put all the data, then some very small images, all are not going to very small category. Some are also going to small category, very less. This is the accuracy. In this particular case, in our customized one, all are matching except one or two. But these are some of the pre-trained data, they are not. Okay, then we trained with 4 or 5 categories. Now we cropped other places also. Okay, every pixel level we cropped, and we found that if there is a little higher size than this, so this is one size, this is another size. Okay, nearby size, they are either classified this class or classified to other class. So from here to here, they are not trained actually. So either because they are not into any class, they will go either this side or that side. What does it mean? It means that this is not overfitted. Had it been overfitted, these pellets may also go to another class, isn't it? Okay. Then another objective of the work was to actually, instead of classifying exactly, you tell what will be the 10%, what will be the less than 10 mm size, what is the 8 to 12 mm size, what is 12 to 14 mm size, what is 14 to 16 mm size, what is greater than 16 mm size. आपको हमको नहीं बताना है कि ये बड़ा है कि छोटा है कि स्मॉल है, उसी में इमेज में से कितना लेस देन 10 mm है, कितना मोर देन 10 to 12 है, कितना इंडिविजुअल को काउंट करके आपको बताना है. तो उसके लिए भी, क्योंकि लेस देन 8 mm रिजेक्ट होता है, ग्रेटर देन 16 mm भी रिजेक्ट होता है. ओके, तो उसके लिए हम लोग क्या किया, नेक्स्ट, so we collected some image, not like that image, that was taking the image from the inside of the disk. These one are the discharge point. Discharge point means when the particles are falling out of the disk, they are actually distributed. They are not one above the other. So your image will look like this. Okay. From this image, we have to find out we have to fit a circle, the particular thing, and then exactly classify the size, measure the size of the diameter of the circle, and do the size classification. Okay. It is circle fitting, calibration, pellet size computation. Next. So here we used UNet for segmentation. Segmentation means you have pellets. Suppose I take an image here, photo. Then I will create an image which will not have any of the chairs. Okay, only the human faces will be there. That means I have segmented, removed all the human faces and kept in another image. Okay, so all the background, everything will be removed. It is called segment. Okay, in a road, suppose a lot of cars are there. So I will segment only the cars, only the bicycles, only the thing. So in this particular application, I have an image having a background. Okay, background may have some dusty things, some cracks on the background, but I will only extract all the pellets. So I'll have another image having only the circles, okay, which are the pellets. So that is called segmentation. And UNet is a particular kind of CNN which is designed for segmentation. Okay? Then we had to modify that to achieve our objective. So you can see these are the few 5 varieties of images. Then this is the ground truth. So we have to do the labeling first. Means you take the image and actually sit on the computer and circle that this particular area and make a picture like this. Okay, this is called labeling. That is called ground truth. Okay. If you don't do, then you cannot train. So now my training machine learning, what it will do, it will take this image as input and these are the desired. Okay. So ये अगर input है, ये निकाल सकता है क्या इससे? Okay. So कुछ network ऐसे निकाल रहे हैं, कुछ network ऐसे निकाल रहे हैं, कुछ network, our network is giving this. And these areas, if you focus and see, they are not good. Visually, you can see that this is more equal to the ground truth. Okay? This is called ground truth. This is more equal. You can zoom it and see how well this is detected. Okay? Then after detection, what next? We have to fit the circle and then find the size distribution. Less than 18 mm, less than 8 mm कितना है? 8 to 16, 8 to 10 कितना है? 10 to 12, 12 to 14, 14 to 16, then greater than 16, how much percentage? And that is possible by a sieving. Suppose during that time they take some of the pellets and do sieving, and they actually tell that this is the actual. Okay, there are holes, bigger holes, smaller holes, then sieve and they do the classification. So manually they did, these blue ones are the manual ones, and our ion pellet with the image processing technique, we generate this by one method, this by another method, this by another method, this is by our proposed method. And you can see the error. This is actual, this is the error. This is actual, this is the our estimation. So error in this case is very, very less compared to other methods. Okay. So this is also published in IEEE Transaction Automation Science and Engineering. Okay. Then we did some work on a real-time data, and we have series of data and with the feed rate and these changes, and we are able to accurately generate the size. This is another the last one. Here, as I told you, by seeing the image, can I see the process parameter? This is also a plasma. Okay. So by seeing the image means I put a camera on the top. Okay. From here, if I put the camera, then I will see a circular thing. Okay, with some glow. Okay. From that glow, can I tell at what current is flowing in this and whether the gas is flowing or not? Okay. This is my objective. Can we estimate the current? Current means what is the current flowing? And the gas flow rate condition from the image. That's the project. That is the objective. So we took 50 ampere current with gas, without gas. 75 ampere with gas, without gas. 100 ampere, 125 ampere, 150 ampere with gas, without gas. Okay. Now I have got how many conditions? 10 classes. Image, we capture a lot of images. In this particular case, 1717, like this, so many images we captured. Now we have a lot of images. Can you not do a program? CNN. So input is this, output is one of these classes. Okay. So camera, image acquisition, processing, CNN based plasma image classification. So confusion matrix compared with different algorithms, and also proposed model. This is also published in. So not very difficult to publish, isn't it? Machine learning is very easy to publish. Now you come to know, yes or no? Or difficult? Difficult or easy? आपका बाइक अगर है तो बाइक से भी भरोसा है. आपका कुछ भी है उसी से मोबाइल से सेंसर, मोबाइल हैविंग लॉट ऑफ सेंसर्स एंड डिफरेंट कंडीशंस आप जनरेट कर दीजिए. आपका कोई भी मशीन है, वॉशिंग मशीन है, या वॉशिंग मशीन में डिफरेंट क्वांटिटी का वेट का क्लॉथ डाल दीजिए और मोबाइल उसके ऊपर रख के साउंड रिकॉर्डिंग कर दीजिए. उससे भी आपका पता कर कितना मटेरियल. सपोज आपका कपड़ा में कभी कभी कीज या पेन्स या कुछ चाबी वाबी रह जाता है, कॉइन वगैरह रह जाता है, तो एक सेंसर लगा दीजिए, अगर कॉइन आ गया तो तुरंत अलार्म है। तो कोई मशीन में अभी नहीं है, आप करेंगे तो यू कैन पैटेंट इट एंड सेल इट टू सैमसंग और समबडी। तो कॉइन डालते ही, कॉइन जब आएगा तो उसका कुछ साउंड आएगा, तुरंत वो उसको ऑफ करके बोलेगा कॉइन इनसाइड। ओके, लाइक दिस वी कैन। I have covered everything. Instrumentation mineral processing can be improved by AI/ML algorithms. Attempts are made to use conventional sensors like accelerometer, camera, photodiode, temperature sensor, etc. Use the sensors data in AI/ML algorithm to design a new applications. We have so many applications. There is unlimited scope, I say. Okay, there is sky is the limit. To apply ML algorithm, opportunity in digitalization. Now industries are going towards digitalization. Any non-automatic or manual things are there, they or human supervisions are there. They want to make it automated. So to make it automated, you have to get the data, real-time data through sensors, and write a program, use a computer. Maybe a small single board computer also you can use, like Raspberry Pi or some other small computers to make a system. So Industry 4.0 and Industry 5.0 is now everywhere people are talking of. So in this also include our AI/ML algorithms. Okay, so you can tell them that if you use this, you will comply to Industry 4.0. So I have completed my talk now. Hope it is interesting, not boring. So I acknowledge the students, PhD students whose work were presented, Sarita, Dilip, Sakti, Arya, and our collaborators. One sir is sitting here, with us because they only tells about their requirements. Okay, we apply our techniques. Somebody has to tell the requirement. What is required in a washing machine? What is required in a ball mill? What is required in a AC? Okay. And there are a lot of industry partners, also a lot of co-authors are there. I could not give the names. And my colleague, Dr. Santosh Kumar there, is a good instrumentation engineer, so we together work. Some of our students have also come here. They have not yet published their news, so yeah, interesting, all right. We have a lot of expectations from them. That is why we have sent them here to get themselves trained. Okay, so new CNNs they will learn and apply there. Thank you.